Hello my dear students. Now we start our next chapter, that is sequences and functions. So we start with sequence. Sequence is a list of numbers or objects in a special order. For example, 3, 5, 7, 9 is a sequence starting at 3 and increasing by 2 each time. Similarly, 5, 8, 11, 14 is a sequence starting at 5 and increasing by 3 each time. So we start with types of sequences. The first one is finite sequence. It is a sequence of n number of terms. That is, in this type of sequences, last term is given. Infinite sequences. It is a sequence of infinite number of terms. That is, in this type of sequences, last term is not given and it goes up to infinite. Now the next one is linear sequence. A linear sequence is a list of numbers that increases or decreases by the same amount, that is by fixed number each time. For example, 1, 3, 5, 7 is a linear sequence because it increases by 2 each time. Similarly, 15, 12, 9, 6 is a linear sequence, decreases by 3 each time. Non-linear sequence. Non-linear sequences do not increase from term to term by constant amount. They include quadratic and geometric progressions type sequences. For example, 2, 8, 13, 17 is a non-linear sequence. Terms. The elements of the sequence are called terms. Since the elements are ordered, we can speak of the first term as A1, second term as A2, similarly the nth term is An. For example, in 1, 3, 5, 7, A1 equals to 1, A2 equals to 3 and so on. Term to term rule. A term to term rule allows you to find the next number in the sequence if you know the previous term. This is also called a recursive rule. For example, if the sequence is 1, 3, 5, 7, then in order to find the next term, you add 2 to the previous term, that is 7 plus 2 is equal to 9. So it becomes 1, 3, 5, 7, 9 and so on. And last but not the least, position to term rule. A position to term rule allows you to compute the value of any term in the sequence. The general formula is An equals to A plus n minus 1 multiplied by D. Here An is the last term or nth term, A is first term, n is number of terms and D is the common difference. Now for example, in the sequence 1, 3, 5, 7, the nth term is equal to 2n minus 1. Now to calculate the fifth term, we put n equal to 5 and we get 9. Similarly, to find the 100th term of the sequence, we put n equal to 100 and we get 199.